Ready? Hi
Yep.
Jonathan, I'm sorry you're out today, and we are picking up here midway after all our questions from homework, and we are putting on a loose end that we left untied from last class. And the question is, what is the derivative if y equals ln of the absolute value of u? We had talked about the ln of u last time, but now we're going to make the more inclusive square absolute value. So we can put in negative values and positive values. When we did that, we noticed we took the case when u was positive, and that was just like what we had done previously. The derivative was established in a previous class, 1 over u du dx. But what happens when u is negative? Well, I can rewrite this statement without the absolute value like this, because I know it's a negative value. Absolute value causes the thing to be positive, so I can write it ln of minus u, because that would create a double negative here, which is positive. And then we know how to take the ln of a negative u. It's 1 over negative u with the chain rule, negative 1 du dx, which is another double negative, and it comes out to the same as it did without the absolute value. But I just had to explain why that was. And so over here we have the most powerful statement with natural logs. So that's the one we want to end with. All right. So that's it for derivative land. As I said earlier, we're going to step into integral land today. Remember, when we take integrals, if the expression after the integral sign is exactly like it is on the derivative land, we can take the opposite answer. Integrals undo derivatives. So let's see how that works in specific cases. If the derivative, I already kind of wrote that up here, say the derivative of ln of x dx equals 1 over x. What would it be if I took, so that's what's floating around in your thoughts. So what would be the integral of 1 over x? So this you kind of carry along in your thoughts. And now I'm going to take this side and take the integral of it. So Brendan, what do you think it would be?
ln of x.
Right, so because the derivative is this, will not the integral take us back to where we started? So we have ln of x, but we're going to use as that answer the more inclusive absolute value of x, because we proved we can, and that has an answer with more values in it, the domain, than the other one. And of course we have to crown it. So back in integral land, don't forget that. So, Gianni, what do you think this one will be?
ln of the absolute value of u
Right.
plus c.
Right. All right, so those, if you have those exact problems, then you are ready to go. Basically, that is the tool that's going to dominate today, but I'm going to add a little complication each time. So once you have that down, keep that in where you can see it. And now I'm just going to do examples. I guess I'm not going to stop at 25 after. All right, I'm going to do a few examples and then let you work on your assignment. So the first one, if you'd write down these few examples, the complication I'm going to add is another constant. So if you would try that one on your lonesome. See if you can foresee what the answer is going to be, even before I do. All right, you're probably done by now. Because the constant can come across the integral sign, we can just move the 2 out in front. Then we have the familiar 1 over x form. So we get 2 ln absolute value of x plus c. So I don't think that complication probably challenged you enough. There is something else I can do to clean up that answer. Does anyone see what it is? Morgan, what else could I do to that?
I'm not sure.
You can use log rules. Does that help?
Oh, you pull back in.
Pardon?
Do you pull it back?
Yeah, so when you're simplifying things, the one out in front can come in back, and then when you're doing the problem, the one in back can come out in front. So what if we pulled it back in front? Do you see anything else we can do?
Okay.
Do you see anything else we can do to simplify that? What do you think, Aaron?
Could you just no? Could you multiply that? Could you put the c in front?
Can you
Does that not
multiply
work?
what?
Just oh no, you can't do that.
Could you do 1 over
Doesn't
x
make sense.
squared?
We already took the integral, so we're happy with that, but I'm just talking about the form of the answer. Brendan, Gianni, anything you see? The thing that you can do here is, because the absolute value is a positive number and squaring anything is also a positive number, we can actually drop the absolute value because those are equivalent statements. I would not take off for that, but I want you to recognize that is true. So, all right, the second example. And this is kind of where we're going to live in our assignment today, is these kind. And you can see the 1 very clearly, and you can see the major piece of work is in the denominator, which is what we're hoping for. I erased my U, let me get it back up here. There's a U expression in your thought cloud as well. So we're going to work that one backwards. So here you see a 1 over a u. What's u again? What is u? I ask you that every day almost. What is u, Morgan?
LNU.
Yeah, what is u? Not the answer, but what is u in general? Why do we use u to symbolize mainly?
I can't remember what it's.
Aaron?
An expression of x.
An expression
okay.
with x in it, which I know you know, Morgan.
Yeah.
You probably didn't know what I was aiming at. So, is this not a 1 over a u? It is. All right, the power of this relationship between ln of u's derivative being 1 over x and going the other way is the fact that if the top is the derivative of the bottom, then you know you have an ln as your answer. So think that through again. If you have an integral and the top is the derivative of the bottom, then you have an ln in your answer. Is that true in this case? Gianni, is the top the derivative of the bottom? How close are we?
Factor of 4.
Right, but the derivative of the bottom is 4. So what I'm going to do is I'm going to tweak this a little bit, and I'm going to put a 4 there. Sounds like a big cheat, but remember I can pull constants across the integral sign. So if I put a 1/4 out here, is this not still the equivalent of 1? It is. So therefore, I have created a derivative on the top and the expression on the bottom. So now the answer is simply, once I get it in that form, the answer is simply the ln of the bottom. And I have to pull that -1, 1/4, not negative. That 1/4 comes along for the ride. This 4 does not show up. It was just in the original setup so that I can get the the integral from the expression plus c. So there we have that one. Let's see if you can tweak the next one and do something similar. I want the integral of x over x squared plus 1 dx. Can you do the same thing with that one? Okay, Brendan, what do you notice? How close is the top to being the derivative of the bottom?
It's just off by 2.
All right, so what am I going to do?
Pull out a 1/2.
And,
Put a 2 on the top.
all right, now what's the answer?
1/2 ln of x squared, the absolute value of x squared plus 1
Right,
plus c.
right. Very good. So you can see this is going to dominate your homework. You're going to be tweaking these. So the top is the derivative of the bottom. So let's see if that's all I have to say. there'll be some, I don't know if I put any trig on there or not, but it works the same way. All right, so let's just stop with that and give you a chance to get started. The homework, I guess Jonathan will have his book. Will be on page, oh, wonderful. I didn't write on the page. Look at your book, I left mine upstairs. 5.2, whatever that homework is on. Here it is. 5.2, let's do number 2 through 28. 2 through 28 evens. What page was it again, Gianni?
340.
I'm sorry?
Page 340.
340. Okay. Page 340, 2 through 28 even. All right. So I want you to start that. If anyone feels like working one on the board, you can do that. That means you don't have to write it in your homework assignment. So, all right, Jonathan, that's it for us. So it was a quick and easy lesson. Hopefully you found it so. And I hope you can catch up and be with us on Monday. Bye.